Yes, everybody, very good evening all, and very warm welcome to the session. I hope that I'm visible, I'm audible and all. Yes, guys. Okay, so it's really nice to meet you all back in this awesome session. Am I visible? Am I audible, guys? Yes? Come on, everybody. Is the slides visible? All right. Fine, guys. I hope that it should be visible shortly. Okay. Yes, Ranjit, today it is going to be molecular biology. Okay. Yes, Tripatim, Himanshi, Preetu, Salu. Yes, Kunal. Good evening, everybody. So, notes are very shortly available for your CSIR NET. Okay. So, if at all you have not yet subscribed, please do think of subscription, and this offer is currently going on. Okay, so don't miss out these offers. And this is myself, Dr. Saranya. Yes, knowledge, Kunal, Shalu, Preeti, Himanshu, Tripadim and all. Okay, this is a little bit about me. I have already completed my Ph.D. in Biomaterials. I have been working with biopolymers and for human tissue implantation. Right, yes. Absolutely. Exam may be conducted in the end of September, Kunal. Maybe in the mid or end. In month of September, definitely it will be conducted. Okay. Yes. So it depends. It depends whether they are going to extend the date for your form collection. So it all depends on that. Right. Yes. And this offer is extended. Okay. So it is extended till 31st of July. Okay. So if at all you have not yet subscribed, please do come with a subscription. You can use the code Saranya Live, such that you will get enough benefit from this block. Okay, right? So this is beneficial actually. For 12 months you need to pay only 13 point. So which is very less. Monthly approximately 1100 you need to pay for learning this much. So this is very beneficial to you. So don't miss out. Enroll at the earliest. Okay. So coming back here, today it is our favorite subject. What is that? We are going to learn about our unit 3. What is that? It is all about our molecular biology. Okay. So the moment you talk about molecular biology, we all will remember about 4 major process, 5 major process, right? Yes. What are they? Number 1, it is going to be the replication. So replication, it is going to be all about your DNA, right? So this DNA synthesis is what is called as replication. Okay. Next, it is going to be transcription, right? Then it is going to be your RNA processing. Very quickly we will see everything today. Okay, right. So after RNA processing, after transcription, the DNA it is going to become RNA. So this is going to remove the introns or unwanted things. Okay, and then it is going to form your processed RNA. Okay, so you're going to form the processed RNA. So then the next step, it is going to be the translation, where this is going to form your protein, right? Next, it is going to be the post-translational modification. Yes, everybody? Is this all clear to you, like how this is all being made and how you are going to make it out? Everybody in the class, did you get an overall idea of what are the key steps that is involved in this process? I hope that you get an idea on this. Okay, fantastic. Good, Tripadi. So, if you take on with replication, okay. So, I am going to ask you questions. You will tell me whether it is going to be true or false. Replication, okay, right. So, in both my eukaryotes and prokaryotes, both of them, they contain Okazaki fragment. True or false? Let it be your prokaryote, let it be your eukaryote. I am telling you that both of them, they are going to contain my Okazaki fragments. True or false? Yes, Kunal says it is true. Vishal says it is true. Yes, everybody. Yes, Himanshi. Correct. So let it be. Yes, Tripadim. Absolutely correct. Yes, everybody in this class. So absolutely it is going to contain. Yes, Preeti, Rumi. Everybody in this class. What you said is exactly right. Yes. So it is going to contain, this Okazaki fragment. So without Okazaki fragment, it is not at all possible. Okay, so you need both your leading strand as well as the lagging strand. Only one difference is there between the prokaryote and eukaryote. What is the difference? In prokaryote, okay, both the leading and the lagging, it is synthesized by your Pol 3, but in case of this eukaryote, your polymerase delta, it is synthesizing the lagging strand, and polymerase epsilon, it is synthesizing the leading strand. Yes, and delta, it is synthesizing the lagging strand. Clear? E is coming now, so it is leading. Understandable or not? Everybody in this class, did you get it? So what about this replication? Is it all clear to you regarding this Okazaki fragment? Okay, right, fine, good. And yes, everybody, and you are going to tell me if at all it is going to synthesize this Okazaki fragment. Okay, so this is part 1, 2 and 3, okay, of this loop of your lagging strand. Okay, so based on this Okazaki, which will be first synthesized? I'll give you options. It is going to be fragment number 3 or fragment number 2 or fragment number 1 or anything. This is the leading strand, this is the lagging strand. Okay, so this is how it is actually occurring. Okay, alright. So but what is the first one that is going to get synthesized? Because it is in this loop, no? So which one is going to be getting first synthesized? Think and answer, everybody in this class. Is the question clear to you? Did you get the logic? See, if at all it is going to have a strand like this. Okay, so 2 strands are there. Yes, very good, Tripadim. Yes, Kunal, correct. So there are 2 strands. Okay, right. So this is going to be your 1, 2 and 3, right? So if it is going to be in this loop, the first, option A, with this loop 3, it is what is first synthesized. Then only it is this one and this one, because I told you that always the synthesis will go from 5' to 3'. So let it be any polymerase. Okay, so kindly note it. Let it be any polymerase. So any of the polymerases, it can move. Any polymerase, it will synthesize only in it will synthesize only in your 5' to 3' direction. No polymerase is available in 3' to 5' direction. So how to 3' to 5' is managed? It is going to make up the loop. Yeah, absolutely. So once this loop is formed, this is going to become like your 5' to 3'. So this is only the direction, 5' to 3'. So this is only getting synthesized first. This is second. This is third. Now got the logic of why it is looking like so? Yes? Okay, fine. So the next question I wanted to ask you is that about my sigma factor. Okay, so imagine that there is no such sigma factor in prokaryote. Okay, right. So you have only this alpha, beta, beta prime and omega. So what will happen? Maybe it is mutated. Something has happened and sigma is gone. So what will happen? So which of the following can happen? Okay, right. So which of the following can happen? So number 1, there is no transcription. Transcription occurs but in a non-specific manner. There is no translation. Both A and C. Which is going to be the correct answer for this question? Come on, everybody in this class, try out for this question. Everybody in this class. Yes, Vishal, Kunal, Preetham, Tripadim, Rumi, yes, Himanshi. Fantastic, guys. So what will happen? Sigma, it is for specificity. Yes, Neha. Sigma, it is meant for the specificity. If there is no sigma, it doesn't mean that transcription will not take place. Who is responsible for catalysis, ma? Which factor is responsible for catalysis? You have alpha, beta, beta prime, omega, and then sigma. Okay. This sigma, it is only for the promoter. So promoter means is only for the specificity. But beta and beta prime is only for the catalysis. This is for your assembly. And your gamma is also going to help up in the things that is running off properly. Okay. Yes. Absolutely. Alpha, it is for arrangement, and beta prime is for catalysis, and your sigma, it is for promoter specificity. So if sigma is not there, it doesn't mean that it cannot bind. Then there won't be any elongation, because what happens after initiation? Who is sent off? After initiation, who is being sent off? Once initiation is over, who will be sent off? Your sigma will be sent off. That is what is called as abortive initiation. Okay. So that is what is called as abortive initiation. Okay. Right. But now it is not required. Got the logic? Now after this, sigma is no longer required. Because for elongation, it doesn't require any of the sigma. For elongation, it is not at all going to require the sigma. So what will happen to the sigma? Sigma will be sent out. Because for elongation not required means it is sent out. So if it is going to be, yes, it is going to be, so it is going to make an abortive initiation. So after that, in elongation, it is becoming, promoter clearance is taking place now, and after that your abortive initiation is taking place, promoter clearance. So elongation, anybody can bind with anything. So that is what it is happening with your transcription. Okay. So will your prokaryotes require any transcription factors? No. Who alone require the transcription factors? Your eukaryotes alone require the transcription factors. Okay. MCM. These are the members of eukaryotic replication licensing factors. True or false? No, Kunal. Abortive initiation occurs when the promoter is kicked out. Okay, like whatever region of this promoter is there, no, that will be converted into your mRNA. Okay, so that part is only called as abortive initiation. because then, yeah, so then what will happen, everybody will be uniform. No, this much variety will not be present. So that is why it is removed by this abortive initiation. Yes, Kunal, Tripadim, Preetham, Vishal, Himanshi, Rumi. Fantastic, guys. So this is what it is, a eukaryotic licensing factors. So prokaryote, the same thing, it is having some other name. Yes, Rumi, Shalu. So this is going to be called as your helicases, that is your DNA B. This is going to be your CDC6, that is your DNA C. This is going to be DNA A. This is the initiator. This is going to be the chaperone. Okay, right. So this is all going to be the eukaryotic replication license and prokaryotic. Yes, Preeti, yes, Kunal, Shalu, Rumi, Himanshi, Vishal, Tripadim. Okay, nice, everybody. Yes, everybody. So now it is clear. Okay, one more time, just telling you what is an abortive initiation. So abortive initiation is a point where this sigma factor is going to be released. So when sigma is released, it is remarking the end of initiation. So once this initiation is over, it is going to go to this elongation. For that step, the sigma is hindering. So the sigma is released. Once the sigma is released, we can definitely make it out to make up a move. Understood? Yes? Okay. So this is what we learnt about replication, and then we learnt about your transcription. In replication, only one compound is till pending with me. So that is going to be your mitochondrial DNA replication, isn't it? So that alone I am planning it for a separate session, such that you will see it in a separate class. Okay, so the next one is transcription. I told you the difference between the prokaryotic and eukaryotic transcription. In prokaryote, you have all in all single enzyme, Rna polymerase. But in eukaryotes, it is not like that. Do you remember what are the types of polymerases you have in your eukaryotes? Yes, as far as your eukaryotes is considered, it is going to have three major types of your polymerases. So this Rna polymerases, it is of three major types. So what are the three major types? It is going to be your Pol 1, Pol 2 and Pol 3. Yes, just a minute guys, the pen is not working. It came back. So it is going to be your Rna, Pol 1, Pol 2 and Pol 3. But in prokaryote, you don't have such a variation. All remains the same. In eukaryotes only, it is going to be different. Yes. So as far as this Pol 1 is considered, Pol 4 and Pol 5 is also there. Correct. So Pol 1 is considered, it is for your rRNA. Pol 2 is only for your mRNA. Pol 3 it is for tRNA as well as the small RNAs. And this 4 and 5 it is going to be this error prone, and it is going to be for the plants as well. Okay, so that is what we have known. And one more thing, question, it is about this alpha amanitin sensitivity. 2, 3, 1. True or false? Alpha amanitin sensitivity. Two, 3 and then 1. Yes, everybody? Got it? Okay. Fantastic, guys. So now this is clear. Any doubts? Let me know, ma. Is it clear? Okay, fine, everybody. Absolutely. Good. Yes. So alpha 2, it is going to be more sensitive. This is less sensitive. This is least sensitive. These two questions are always asked, right? Favorite question of CSIR. Okay. So coming to the transcription factors. As far as your Pol 1 is considered, what are the transcription factors? SL1, UAF, upstream binding element, UBF only, no? Okay, SL1 Tata box binding protein. So this is only going to make it. This is going to be your transcription factor to DABA. Yes, FEC, isn't it? Okay, right. And then it is going to be your 3. It is box AC, AB and all it is there. So 3 things are there. And then PST, Oct, Tata. All the things you should, yes, DABFEC, correct. I think this A is wrong, correct, DABFEC, correct. And one more thing I told you regarding this one. It was regarding your binding of your transcription factors, where it will bind. The transcription factor, it is going to bind in the major or minor groove of your DNA. So where your transcription factors will bind. It is major groove or minor groove? Yes, do you remember that they will be binding with this groove only, isn't it? Yeah, so you have 2 types of groove. One it is the major groove and other one is the minor groove. So where will your transcription factors bind? Do you remember this? Yes or no? We saw in detail about this. Yes. So they will bind only to the major groove. So who will bind the minor groove? So this is going to bind only to the major groove. So who will bind to this minor groove? Yeah, this transcription factor, it is, where is my pen? My God, just a minute. So transcription factor, it is going to bind the major groove. Your histones, yes, histones, it is going to bind to the minor groove. Am I right? Do you remember this statement? Yes or no? Think and answer me, guys. Yes? Absolutely, ma. Very, very important point to be remembered for your preparation. Yes. So transcription factors, it is going to bind to which groove? Got it? So where will the histones bind? Histones, where it will bind? Histones will bind to your minor groove. Yes, absolutely. Histones must bind to the minor groove. Okay, right. Only these fellows will bind to the major groove, transcription factors, and this. Yes, everyone, no more doubt on this. I was just checking you. That's only, you're right only. Transcription factors will bind the major groove, and the histones, it is going to bind with the minor groove. Okay, fantastic. So the next one, yeah. So the next one, it is going to be the RNA processing. So under this RNA processing, you have a cap and you have a tail, right? So what is this cap? It is addition of 7-methyl-guanosine. This is going to be the cap. Can it be added directly? No, it cannot be added directly. So what is needed? First hydrolases to trim them, and then what is needed? For capping enzyme. So your capping enzyme is absolutely required here, isn't it? Right. So once your capping enzyme is ready, then only, so your gamma phosphatases will remove your gamma phosphate. Which gamma will be removed? All your alpha, beta, gamma? Only your, this gamma is alone removed. Okay. And then to this alpha and beta, one more alpha is going to interact. So from where this alpha has come? This has come from your mRNA. right, because here it is going to lose your PPI. So alpha, beta, gamma were there, no, beta, gamma left, so only alpha is there. So that alpha and this beta, it is going to form a bond. And then guanyl transferase, 7-methyl guanosine transferase, with the help of your SAM, S-adenosyl methionine, it is going to give this. Do you remember that? Yes, everyone? Can you all see me now? Yes or no? It got struck between, or am I there? Okay, it is visible now. Alright, so you can see that, yes, so there is going to be an important enzyme called as this phosphohydrolases. Okay, so this phosphohydrolases, it is blur. Is it room? It is blur. Just a moment. Still buffering. I'll write it for you, don't worry. So the first one, still buffering, amma. Now it is okay, no? Okay, fine. So it is going to be your, yeah, okay, Shalu, nice, nice. So it is going to be your hydrolases. Okay, right. So once your hydrolases are done, next which fellow is going to come on with? Yes, after the hydrolases, who came? Come on guys. So after the hydrolases, it is going to be the, after your phosphohydrolases, it is going to be the, make it fast, guanyl transferase. Okay, so the second enzyme, it is going to be, yes, Amrita, guanyl transferase. Okay, so after the guanyl transferase, there is going to be the guanyl methyl transferase, 7-methyl transferase. Okay, so this is what is going to be the capping enzyme. So this 7-methyl guanosine methyl transferase is going to be your addition of your capping enzyme. So this is obtained from S-adenosine methionine. This is only going to donate your methyl group. Okay, so then only it is going to come. And then if you take up with the tailing, so tailing is nothing but it is going to be adding up of your AAAA residue, homopolymer tail, up to 500 it will be added. Okay, so initially it was thought to be 200, now they say that 500 are added, poly A tail is added. And this is also occurring not just as a single one. Yeah, first there is going to be this cleavage. Okay, so this is what is done by your cleavage factor 1 and 2. For that you require this cleavage stimulation factor. Okay, and then only your polyadenylation polymerases will come. And then you have the stabilizers to make them to stabilize. Okay, poly A polymerases and then poly A polymerases binding protein. So all these key terms just to check if you have done. If you have not yet done, it is high time that yes, and cleavage and polyadenylation stimulation factor, cleavage stimulation factor, cleavage factor. So all these things are very important. Just check out whether you remember this point or not. Okay, clear? Yes, everybody? Okay, so that is about your RNA processing. Once it is done, then there is going to be your protein synthesis. So in case of my eukaryote, do I have my formyl methionine? In eukaryote, do we have any formyl methionine? Have you ever heard? In eukaryote, there is going to be this formyl methionine. No, this is not at all there in eukaryotes. It is only with the prokaryotes. Okay. So in case of your eukaryotes, this ribosome itself is different. In case of prokaryotes, protein synthesis is carried over by ATS. Yes? Is it so? ATS or 70S? Fast. In prokaryotes, what yes it is? Make it fast. Prokaryote it is 70 years. Eukaryote is 80 years. This 80 years is only split into 60-40. 70 years is split into 50 and 30. This is the small and this is the large subunit. And also you have to learn about all the inhibitors. Okay. So for example, if it is going to be nocodazole, it is an inhibitor of your DNA. Then yes, absolutely. Then if at all it is going to be with your tetracycline. So where it is going to affect, you have to think and answer. Okay. Puramycin. Yeah, replication it is nocodazole. Puramycin. At which stage it is going to make it out. Yes. So whether it is going to be your 30 years or 50 years, all the things you have to know. Okay. Right. Everything you have to know. Yes. Yeah. So it is an analog of your amino-acyl tRNA. Everything you remember, I guess, but still I'm just warning you to revise everything and go before the examination. Then in the termination, it is by the releasing factors 1, 2, 3. Okay. Alright. And that is what is going to take place in termination. You have your EPA site, and this will move also in 5' to 3' direction. It will move from your N terminus to C terminus. If it is an artificial synthesis, then it is from C to N. But your natural protein synthesis will always move from N to C. That part also you have to remember. Oh my God. Thank you all. Thank you so much for your compliments. So this EPA, what is this E site? What is this E site? E, it is going to be the exit site. What is P? P is what is going to be the peptidyl site. So here you have this enzyme. What are the enzyme? Peptidyl transferase. Isn't it? It is acting. And then A, it is going to be this amino acyl site. This is usually the entry site. Okay. But if it is going to be your initiation, yes, if it is going to be your initiation. So now directly your formyl methionine tRNA, in case of prokaryote, your formyl methionine tRNA will jump into the P site. It is not going to wait for A and then P. Directly it will go to the P. So it is going to move in this direction now. So this is first EPA, this is next EPA. So whatever in this earlier thing it was P, it will now become E. Okay, right. So tRNA will go out here. Okay, so this peptide is going to make a jump here. Okay, so now an incoming tRNA is coming inside. Okay, so this is how it is being made. So already there is a bunch. So it is going to get transferred here. So this one is going to become now a exit. So this P, this earlier P will now become your E. Next, this is going to have all the bundles. So that is growing always in your N terminus to C terminus direction. Clear? Yes? So it is growing in your N to C terminus. Sorry, I have put the direction the reverse way. This is the first one. This is the formyl methionine. This is the N. This is the C. It is always growing in this direction. So the new one will come and sit here. Okay, so like this it will grow. So that is the N to C combination. Did you get this N to C combination? Everybody in this class? This will remain the same. Okay, so usually whenever you are putting like bead experiment you have done, so there is a knot here. Okay, right. So you are going to put the bead in this direction. Okay, so this is N and this is C. So this is only keep on growing. Did you get it? Everybody? So no doubt on this N to C direction, right? Yes? Okay, absolutely. So this is what is going to happen, and this is a very important step in your protein synthesis. Okay, so apart from that, there is going to be your post-translational modification. In that you have to read about your phosphorylation, your glycosylation, and ubiquitination, and then sumoylation. So all these things are quite commonly that is taking place along with the organelles of interest. If you study, it is going to be of great help to you. Yes. So did you get an overview of all the things that we read today? We just made a very brief thing. Okay, so don't worry, in one more session we will make it up to the fullest. and if you find something inappropriate, you can definitely report up. Yes. Okay, fantastic guys. So that's all folks for today, and tomorrow we have a lot of sessions. Okay, so tomorrow we have a session of YouTube at morning 10 a.m. okay, right? So don't miss out those important sessions. All the list is out. 10 a.m. we have a session, 12 p.m. we have a session, and as usual 5 p.m. we have a session. So 3 sessions are there. And also, if at all you have not yet subscribed us at Unacademy, please do make out with a subscription. So not only at YouTube but also at Unacademy app. So Unacademy app is seriously helping you all to make out the best. Okay. Yes. Yes, definitely. If you studied this unit 7 and unit 8, you can boost your score. Okay, absolutely. So all other units you must focus, but this is going to be sure. For post translation, I'm planning a separate session. That is why today I didn't mention it much. Okay, so nice everybody. Definitely I'll catch you up in another interesting session. Take care till we meet. Thanks a lot guys.